A very good afternoon to all esteemed gathering here for the second week of Teacher Enrichment Workshop entitled as Differential Equations and Mathematical Modeling in collaboration with the National Center for Mathematics, a joint center of IIT Bombay and TFIR Mumbai. Firstly, I would like to request all the participants to please keep your mic at the mute mode so that we can have the smooth functioning of this session. Now, in continuation of our previous session in the last week and this week also, today we are really very privileged to have with us our expert speaker, Professor Kapil Sharma sir. Sir, we are really grateful to you for providing your precious time for this TEW and investing your sincere efforts for all the participants for this TEW. And we really hope that all the participants will be benefited with your profound knowledge and expertise in this field. Professor Kapil Sharma sir completed his post-graduation in mathematics from Kurukshetra University and then qualified National Eligibility Test for Lecturership conducted by UGC and Graduate Aptitude Test in Engineering conducted by IITs. He had been awarded Junior Research Fellowship to carry out research towards his PhD at IIT Kanpur. His PhD dissertation established a theory for the numerical study of boundary value problems for similarly perturbated differential difference equation, which is one of the important area, under the guidance of Professor M.K. Kadilpaju sir, and received his PhD degree from IIT Kanpur in 2004. In the same year, he joined the Department of Mathematics, Punjab University, Chandigarh, as a faculty member. In 2005, he had been awarded with prestigious INRIA postdoctoral fellowship and joined Bordeaux University, France, where he worked with Professor Jack Henry, director INRIA, and developed a new concept in the simulation of elliptic type partial differential equation, which they further named as computing zoom technique. In 2008, he joined the editorial board of one of the renowned journal as Applied Mathematics and Computation. It is really one of the leading international journal in the field of applied mathematics, and it is published by Elsevier. He has more than 20 years of research and experience. He guided 7 PhD students, and 3 students are currently pursuing their PhD under his supervision. And actually, the list is very long, but I have mentioned here only the few one. So, sir, we are really thankful to you for accepting our invitation for this TEW. With these words, I would like to request Professor Kapil Sharma, sir, to please start the session.
Thank you, ma'am, for providing this platform to interact the young researcher. And really, I'm very grateful to you and your faculty member, particularly Professor Alka Tripathi and Professor Mittal. I'm really very enthusiastic to be a part of this workshop, and of course, as a resource person. So today I will try to convey our views on how the methods for solving the initial value problem might have evolved. Not only just just tell that how these are working or its convergence analysis. My focus would be that what might have the researcher were thinking when they were developing the, and I hope it would help the audience a little bit that how to proceed to the research or to tackle the research problem, particularly in the area of computational theory. So thank you, ma'am. So I will start. So I hope before me, how many sessions were conducted?
Sir, in the last week, every day we have 2 sessions. That means around 12 sessions in the last week. And on the Sunday, we have the 3 tutorials.
Okay.
And then after in this week, this is the fourth day.
Okay.
And in the previous 3 days, we again have the 2 hours lecture per day. So in total, 18 hours has been spent for the expert lectures and 3 hours for the tutorial sessions.
Okay. So audience is quite exhausted, maybe. So I think, but I attended the first one, on the inaugural session day. So in that day, I think the initial value problem were discussed, initiated.
Right, sir.
So it would be very helpful for me. So what else have been done?
So, sir, they have given the description about the initial value problems, how to solve this type of the
And
equations.
then PD, we move to PD, conservation law might be.
Yes, sir. Yes, sir.
And
We covered the conservation law only a little bit, not
okay.
to the large extent.
Okay. And any other, I mean, lecture on ordinary differential equation, or only
Sorry, sir.
any other lecture were all also on differential equation?
So we have few lectures about the differential equations, and they covered different type of the solution or different type of the topics related to differential equations.
Okay.
So like a few have discussed the classification of the PDE
Okay.
and a few methods for solving the differential equations by
Numerical
variety of
method.
the techniques.
But I think nobody might have discussed the solution of initial value problem.
Yes, sir. Yes, sir.
Techniques. Okay. So how many participant? I think around 25.
Sir, as the number shows, it is 32, including each and every one, and this will be increasing one by one because few one has the classes right now, so
Okay.
they will over their class by the 3 o'clock and then switch
Okay.
to this
Then
session.
they will come.
Right, sir.
They will join. So, okay, I can wait, but it's already 36. So I can wait 2-3 minutes more, and then we will start. So participant are from might be across the India. Or,
Yes, sir. Yes, sir. Across the different parts of the India, we actually have the participant from each and every part of the country. Like from southern India, also we have a lot of the participants, and few participants are from Delhi University and from other institutions and other colleges, and few are from Gujarat also.
great. Actually, this is the
So
benefit of online lecture with some
actually, this is the only benefit of the
only
online.
benefit. Yeah, I understand. Actually, in mathematics, it is difficult for us for online teaching. Otherwise, maybe in theoretical.
Right, sir.
नमस्कार और कैसे हैं सर बढ़िया so should I start
Yes, sir.
okay so basically I will try to convey first numerical analysis it's visible board okay you have to give me I can share
Yes, sir. You can share it.
Yes, sir.
So I will start from the numerical analysis a little bit, and then we will move to numerical analysis for initial value problem. So,
Right.
so or I can write in short form numerical. So anybody can tell what do you think by numerical analysis?
So,
Numerical analysis is kind of analyzing the solutions where we cannot find the closed or the analytical form of the solutions of the problems of differential problems.
Okay. Anybody else?
Or theory of methods to find approximate solutions.
Theory of
Methods to find
approximate
solutions.
solution of a mathematical problem.
Yes, mathematical problem, sir.
Yeah. Anybody else? So basically, if you look that we can divide this into a two part. If you agree, some numerical plus analysis. Am I right? Means numerical, you can understand some kind of numbers and some analysis. So we can, formulate a good definition. Maybe you would not have in the textbook on numerical analysis, but I am sure that you would be convinced with this definition. So if I say that number one, numerical analysis is consisted of number one, the development of methods, the development of methods to find approximate solution of a mathematical problem. So you may note it down, the development of methods to find the approximate solution of a mathematical problem. What I mean mathematical problem, it could be a differential equation, it could be algebraic equation, it could be fuzzy problem, any mathematical problem. Number second, when we say that it's a approximation, so it means that there are some error. Am I right? Because we don't have the exact information, so it means that we have some error. Am I right? So the second component, that the analysis of error occurred in the approximation. Am I right? Are you agree? Hello?
Yes, sir.
Yes, sir. Yes, sir.
Yeah. So because keep responding, so that otherwise maybe not you, I may be slept. So this is consist of two component. One is the development of method to find approximate solution of a mathematical problem, and the second is the analysis of error occur in the approximation. So now we have to justify that why we should do whatever we are doing under this umbrella numerical analysis. What is the need of that? Am I right? Otherwise, we should not do the things just for fun. There must be some motive. Am I right? So anybody can tell that what is the motivation of the first part? Because actually I am not writing, because it's very difficult for me to writing. So I hope you people are noting on your notebook, and it
Yes,
will
sir. We
not.
are noting the important points as you are mentioning.
Yeah,
We
yeah.
are noting.
So can now anybody tell that what is the need of doing the first component? Means the development of methods. I'm not saying the approximate method. I'm saying that development of methods to find approximate solution of a mathematical problem. Hello?
Sir, as you, I mean, as just we discussed that the need is like again the same thing when it's not possible to get the exact solution or the closed form of the solutions of any system, whether
Rather
it's a
than closed form, we should say that exact solution.
yeah
Am I right?
exact solution. That is what.
Exact solution. It's fine. Really, you are absolutely right. That in
Then
most,
we develop some kind of methods or techniques to approximate the solutions step
yeah,
by
yeah,
step,
yeah,
the
yeah.
iteration concepts.
Yeah. That is the another thing that we
Okay.
either we will do iteration, we will do direct method, or another thing. So many things would
Okay.
be there. But you are absolutely right that we do not have tools to find the exact solution of a mathematical problem, or several, or I would say that most of the mathematical problem which model the real life phenomena. Am I right? Because we are interested.
Yes, sir.
If
Yes, sir.
I am just going away from this topic, so you see that what is a basically, if I ask you that what is a use of mathematics, or why we should study mathematics, because
Definitely to solve the real world problems, basically.
yeah,
Yeah.
because basically uh, basically, if you observe that, I will give one example or one problem for which you would be convinced that if you see that in journal or in real life, the most common problem is to have prediction for future. Am I right?
Yes, sir.
If today we would be able to know that how much population would be of Noida after 10 months, 10 year. So this information is very useful in many ways. Am I right?
Yes, sir.
We can plan, we can make our policy accordingly. If suppose I need to go to outside, okay, it's unknown number and coming again and again. So I think I should take a call just for a moment, please. Excuse me. Yeah. So suppose I'm planning to go outside on the weekend, and the information that whether it would be a rainy day or non-rainy day, or weather forecasting would be important. Important information, maybe in financial forecasting also. So I mean, anything if we know about the future, so that is a very important thing. Am I right?
Yes, sir.
Yeah. So to have these information, we have more than one way. One way, suppose I ask you that how would be the weather of Noida in the month of December. Based on your experience, you can predict. Am I right? You
Yes,
would that it would be
definitely we go for the December weather.
yeah, yeah. In this
We
it
collect
would
the
be
data. Yeah,
winter.
we collect the data
Yeah, or collect the data, or based on our experience. I am saying that these prediction can be obtained in more than one way.
yeah,
Am I right,
yes,
ma'am?
yes,
If I ask you, so you would say that, or based on experience, you are living maybe more than 10 year in the Noida. So based on your experience, you can say that it would be, winter
yes,
or
sir.
summer, or whatever the weather would be. So that can be. Maybe another way, we would go for some astrologer,
Yes,
but
sir.
the most reliable way, or reliable information or reliable prediction which we can get using the mathematics. And how we do that? First, we convert a real life problem into a mathematical problem, and then we solve that problem.
Yes, sir.
Am I right?
Yes, sir.
So how we do that? Suppose I think being a student of mathematics, so I can took a liberty rather than doing all the calculation. I can just give the example. Suppose I think most of we know the heat equation. Am I right?
Yes, sir.
Heat equation. It's a second order
Partial differential equation.
partial differential equation. Am I right? Ut is
Yes,
equal
sir.
to
Ut is equals
U.
to CUXX, if not wrong.
Yeah, you are absolutely right. Ut is equal to C U X X. So basically, what is U? If suppose U is a function of xt, X is the suppose. So basically, it is. I'm telling you. I'm not going how to model that, but just I'm explaining. So
Maybe this is some kind of rod, you can say, if it is a one-dimensional.
heat source. It's a thin rod, so we are assuming that only. I mean, 1D problem. So it
Yes,
means
yes, sir.
if we see the temperature of the point at the cross section, so it is uniform. So it's heating. It's heating basically. It's a heat source and heating. So temperature it's basically
Starts increasing.
or increasing. We can say that. So if you see that our U belongs to two parameter here. Am I right?
Yes, sir.
U depend on U is a function of or depend on two parameter X and T. What is X basically? X is the distance of the point from the heat source and T is the time. Am I right?
Yes, sir.
Suppose we are talking about this point. So we suppose we have 2 point A and B. So if you observe at the same time, if you observe the temperature of the point at A will be more than the temperature at the point B. Am I right?
Yes, sir.
So U temperature depend on the heat, depend on the distance distance of the point from the heat source. And another thing, that if time increases at the same time, if I observe that the temperature at I mean 10 o'clock and then 11 o'clock, so the temperature at 11 o'clock is more than temperature at 10 o'clock. Am I right?
Yes, sir.
As time increasing, so temperature also increases. So
Increasing.
now what is our basic real life problem? Our real life problem, I wish to measure the temperature at a different point and at different time. So how we will do that? By experiment we can do. Suppose we wish to have the temperature, we wish to measure the temperature at some particular time t0. So we can end at point this point. So we can do that using the thermometer. Am I right? But
Yes, sir.
if we change that, so again that we can repeat that process. But in that way we have infinitely many points. Am I right? Somebody
Yes, sir.
wishing at
Yes, sir. Yes, sir.
yeah, somebody at this point. So in that way, so can we get this information using some mathematics? The answer is yes, affirmative. Fortunately, we have this phenomenon is modeled by a very nice partial differential equation, for which we have fortunately the exact solution also for this problem.
Yes.
So how we
Yes.
do that? If you observe, so what's happening basically, heat is we are giving heat to the system, and that heat is diffusing in the system. Am I right? In the road. it's happening. So this is the physics of the problem. So using the physics of the problem, we will convert this problem into a mathematical model or mathematical problem. That's basically what's happening. Rate of change, rate of change of temperature, basically heat is equal to rate of change of temperature we are giving, and that is diffusing with respect to x. So rate of change will be represented by the first derivative. So ut is proportional to uxx, because diffusion is represented by the second derivative. Am I right?
Yes, sir.
So ut is proportional to uxx. So we can remove the proportionality sign using the physics of the problem, that c times u x x. Am I right? And c depend on the several factors, that the material of the wire, rod, and so on. So now rather than measuring the temperature at different point and different time, now our problem is converted to solve this heat equation or this partial differential equation. Am I right?
Yes, sir.
Now
Yes, sir. Yes, sir.
suppose we solve this partial differential equation. We can find how to solve a differential equation the best way. Anybody can tell?
So
we
partial
can use
differential
Fourier
equation can be solved by
transformation.
separated variables also.
Yeah,
Separation
there
of
are.
variables.
Yeah, there are technique, but the basic technique, or we can say that the basic is just to in some way do the integration. Am I right?
Yes, of
Yes,
To
course.
get rid
Yes.
of, basically we have to get rid of these derivatives. Am I right?
Yeah. Yes, sir.
I'm looking for you. So it means that just we have to integrate in some way. Am I right? So how
Yes,
many
sir.
derivatives here we have? One with respect to t and two with respect to x. So when we integrate so then we have constant of integration. Am I right?
Yes, sir.
So if we integrate this, so we have basically three parameter will be involved. Am I right? One because of t and two because of x. So it means, and how many solutions we will have then, as we are changing the value of these parameters, so we are getting one another solution. So that way we have infinitely many solution. Am I right?
Yes, sir. Yes, sir. We will get
Yes, sir.
infinity.
Yeah, infinitely many. But suppose I ask you, I ask you that please tell me the way to go to Kannad place from Noida. Rajneesh, if I ask you and you told me, or you tell me, the more than 10 ways. Sir, you can go this way, you can go that way. So I would ask you that, okay, Rajneesh, please tell me the one best way. Am I right?
Yes, sir.
Rather
Yes,
than,
sir.
so
Easiest way to do
basically,
with separation of variable or Laplace transformation.
yeah, but by any method, if you solve this, so you will have infinitely many solutions. But but I am interested in a
Yes,
unique solution. Am I right? So
Yes,
to
sir.
have
we
unique,
can take Dirichlet condition. We can.
pardon?
If we have Dirichlet condition, then we will get unique solution.
No. Just
No, no,
I
sir.
mean, it is the
If
second
we have
step.
some,
Yeah,
sir, we have many ways to go to CP, but if
yeah,
you mention some condition like
yeah.
I would like to get this
Good,
particular
very good.
place,
Yeah,
then only you can go. That is called a particular solution.
yeah. If you put, so many conditions, n number of conditions, so that I would go on a unique way. Am I right?
Yes.
So
Yes,
same
sir.
thing we will do here. Am I right? Because here three parameters are involved, so we have to fix all three parameters. Am I right?
Yes, sir.
Rajneesh, are you agree?
Yes, sir.
So then we
Yes,
will
sir. Yes,
see
sir.
whether
Agree.
we will prescribe this type of condition and that type. That is another thing. First, we have to how many condition we require and how to prescribe. So that is another way. But condition, so 3 condition we need to specify, and we have to specify these conditions in that way that, I mean, that is also depend on the physics of the problem. From there we can have the information. So we can have the information initially. We can get whatever by experiment or by any ways. So we could have the temperature profile initially. Once we know, so we specify that we know u x at t equal to 0. So initially we know the temperature profile of the road. Let's assume this is gx. This is gx. Another condition, 2 condition we have to impose on the
ut of x0.
pardon,
ut of x0. Del u upon del t at x0.
del u upon del t, but
Del
initial
t at,
profile, initial
yeah,
profile, del
at
u
t equal to 0 is fx.
t is equal to 0, so it's a gx or whatever you can take fx. So
Yes,
just,
sir, yes.
yeah, it's a function, basically it's a given function. Am I right? We know that this
Yes, sir, because t is 0, then ultimately it will be the function of x.
function of x, and this is a known function. It should be a known function. Another, we can maybe I suppose I am heating here rather than at the corner, or maybe I can start from other point. So maybe I am heating here, and some way I would be able to keep the temperature constant at both the end. We can do some by some experiment or physics, we can do that. Suppose we have constant temperature at the 2 point. We put these in the suppose fridge point, and we kept that temperature at 0, or maybe at some constant temperature, basically. So another 2 condition we will satisfy that we will have with respect to x. So suppose its length is L, so u at 0 t is equal to some constant, say alpha, and u at, or you can take 0, whatever you are taking, and
That means boundary condition, sir. Right?
yeah, in that way we will
Yes.
specify the boundary condition. So it's suppose L for all time, it is also T. So now we have converted our real life problem into a mathematical problem or mathematical model, which is consist of 4 equation. Am I right? One is this differential equation, another these 3 condition. So once we have converted our real life problem into a mathematical problem, so then we talk about its well-posedness. Am I right?
Yes, sir.
Well-posedness.
Yes, sir.
So, do you understand the meaning of well-posedness of a mathematical problem? Not only the differential equation, any mathematical problem in general. Anybody can answer?
So well-posedness, if I'm not wrong, then we understand in this way that if we give any kind of little bit perturbation around the solution, then it will come. I mean, if we change the point, sorry, not the solution. If we change the point around that x comma t, any neighborhood around the neighborhood, then it will gives you the. Sorry, मतलब मेरे को लग रहा है शायद.
Yeah. You are, I mean, some way close to answer. Anybody else?
So the initial disturbance is not affecting the solution and the problem.
Pardon? Please
The
repeat.
initial
Yes, yes.
change or initial disturbance to the problem at time 0, say it is not changing the problem. solution, it is not affecting very much.
Good, good. And anybody else can say?
Actually, sir, approaching the solution while considering all the constraints, sir.
Okay.
Okay.
Anybody else?
Sir, could you please repeat the question? Actually, I have some
Yeah.
internet issue.
Yeah. Question is that once we have converted a real life problem into a mathematical problem, am I right? So we have
Yes,
converted
yes.
this real life problem, this one, into this mathematical problem, which is consist of 4 equations. Ut is equal to cu xx, and
Having
ux0 is equal to gx, and u0 t is equal to 0, and ul comma t is equal to 0 for all t greater than 0. Am I right? So once we have converted this, so our next step would be to check the well-posedness of this mathematical problem. Am I right?
yes,
So I am
yes, sir.
asking that how you will, define the well-posedness of a mathematical problem, not only the differential equation problem. So this is the
Yeah,
question.
at least you should be continuous,
You should be
continuous and well defined.
only but you say okay continuous, but here continuity is only sufficient.
Derivatives should also be continuous.
Yeah, derivative also the continuous. Yeah.
Yeah.
So rather
That
than
means
we talk about this. Yeah. Tell. Kapil.
C2, it should be C2,
Yeah.
continuously
For
differentiable,
this
second order.
particular problem, one is this one. Yeah. But I am talking in more general way. I'm talking in any mathematical problem. It could be an algebraic problem. It's fine.
Mm, yes.
Anybody else can try something? So please just speak out. It's hardly matter
Prof,
whether
well-posed technique has a solution, and the solution is unique, and the solution depends on continuously on the initial values.
yeah, this is very right. So number one, we will talk about the solution. That problem has a solution. Not only has a solution, it has a unique solution. Am I right? Whatever problem we are have, the number one is problem must have a unique solution. The next one, not only
Existence and
but
uniqueness.
when I am saying that
Solution
problem
should
has
be
a
unique.
unique solution, so it means existence would be implied. Am I right? If I am saying
Yes,
that
yes, sir.
problem has a unique solution, so yeah, you can say that problem exists, has a solution, and secondly, you can say that it must be unique. So I said that problem has a unique solution. So both are the same thing. And the next, the second one.
Is the continuous dependence? Then that means a small
Yeah.
change in initial condition
Yeah.
does not
Continuous
have
depends.
drastic change in the behavior of the solution.
Yeah. Which what's your name is ma'am Lakshmi ma'am, or it is
Stability. Stability means if you are having
yeah.
a
Yes,
small
sir.
change in initial
She
condition,
was
solution of
discussing,
solution does not.
and other
Yes,
was
sir.
also discussing. So same thing. That
Yes, sir.
the solution. The first one is the problem must have this unique solution. The second one, the solution must be continuously depending on the input or given data. Am I right?
Yes, sir.
If
Yes,
I
sir.
am making a small change in
Initial data.
initial data or input, so that output, the change in output must be bounded by that. Am I right?
Yes, sir.
So
Yes, sir.
this gives the concept of stability. If
Right, sir.
am I right?
Right.
So in that way we define. So we check with, I think all of you are aware about, because this is a well posed, a well celebrated problem. So it is a well posed. Then we will go to the solution methodology. So fortunately, whatever I have given the example, so for that problem we have method to find the exact solution. Am I right?
Right, sir.
That is
Right.
variable we can find its solution. We have the nice solution
तो
for.
अगर एक बात मैं आपसे पूछना चाह रही थी कि वेल पोस्टनेस ये तो सारा मैथमेटिकल टर्म्स हम जो यूज कर रहे थे दे ऑल आर द मैथमेटिकल जार्गन्स बट इन जनरल जब हम न्यूमेरिकल अप्रोच कर रहे होते हैं तब भी तो प्रॉब्लम वेल पोस्ट ही होती है बट ये होता है कि बस उसका एग्जैक्ट
नहीं तो
फॉर्म नहीं आ
मैम
रही
वो
होती।
तो अभी आप देखिए ना, you see अभी हमने we didn't talk about the numerical, just
Yes.
we are talking about the well posed. Now the second
Yes.
step, once we have
Okay.
we have a well posed mathematical model corresponding to a real life phenomena, so the next
Okay.
step to find the solution, exact solution, the first
Right.
should be the exact solution. Am I
Right.
right? And fortunately for this problem we have a exact solution.
Right.
So this thing is clear.
Yes, sir. Yes, sir.
Am I right? So now I mean we need not to worry about the numerical or approximate, or I should not say that numerical solution. What is the meaning of numerical? We should say that approximate solution. Am I right?
Right. Right,
The
sir.
approximate solution. It could be, you will see in approximate solution also could be a closed form. Am I right? In
Yes, sir.
Taylor's
Yes, sir.
approach, if you would remember, and we will study in
Yes,
Picard,
sir.
so we get the solution in a closed form or continuous
Closed
solution
forms.
we are getting, but
Yes,
that
sir.
is
Yes,
an
sir.
approximate solution.
Right, right, right.
Am I right? Unlike to the solution we obtained by the Euler's method.
Yeah, for simple problems like we always have these.
Yeah, so we will study
form.
that also. But here my if you observe, I move from one point to justify the one point. Am I right?
Yes, sir.
So
Yes, sir.
it's fine. So you understand that how we use the mathematics to solve a real life problem. So my
Yes, sir.
objective is here. Now still I'm coming back to our objective, that to justify that why we should develop the method to find the approximate solution. Am I right? But whatever I have given this example, so by this example I would not able to convince you, because whatever example I have given, so you will see that you will see that you all I mean found its solution using a separation of parameter and variable. We can find the solution. So now I am giving you another example for this to convince you. Suppose you might have studied V.D. Sharma sir taught this thing, if I remember, I saw in the first day y prime is equal to fx y you would say, sir, we have solved a very complicated problem and it seems to be very trivial one. So, and we know that y at x naught is y at x naught is equal to y 0. Am I right?
Yes, sir.
Y prime is equal to fxy, y at x0 is equal to y0. So in the first lecture, sir taught you. Am I right?
Yes, sir.
So under certain condition, this is also a well-posed problem. Am I right? As a unique
Yes, sir.
solution.
Yes, sir. Hadamard well-posedness condition is required.
Yeah. So you are aware. So now I am claiming. Just you can counter me. What is my claim? My claim is that. What is my claim? We do not have any method. We do not have any method to find its exact solution. Did you heard my claim?
Yes, yes.
Yes, sir.
So anybody can answer? Anybody have any technique to find the exact solution of this problem?
If some problem is simple, like we are talking about the linear differential
Wait,
equation,
wait.
so we can find the exact solution. But if problem is highly non-linear in nature, so we will only discuss the what is happening in the long term. Either the solution is existing or the solution is unique or not, and
Okay.
we can also talk the continuous dependence of this problem.
Okay, Rajneesh, I say that. Okay, Rajneesh, can you tell me that how would be the weather on the, coming Monday in Noida? Where you belong to, Rajneesh?
Presently here in Noida, sir.
Okay, you are in Noida, so it's fine. So if I ask you, Rajneesh, please tell me that how would be the weather of Noida on coming Monday? Then you would say that okay, sir, it's exist. The weather would exist and
No, sir. But real life, the problems is
because,
very stochastic in nature.
yeah, because you want that I want that, yeah, whether it would be a rainy day or non-rainy day or it would be a sunny day or that information I require, or what would be its temperature, so many things. Am I right?
Yes, yes,
So
sir.
Yes,
Yes,
sir.
sir.
I need the information. Maybe I would not expect. I can say that okay, just give me that rather than suppose it would be a rainy day and. Rather than I would that if it would be a rainy day, then how much raining it would be, happy that if you say that it would be a rainy day or non-rainy day. Am I right? This I can expect. But if you say that okay, it's a well posed that it's exact, it's exist unique, but I don't know that how would be the weather. Eh? So that thing, but now I am looking that tell me the solution. I'm asking that whether we have any technique, any method, hmm, any method to find its exact solution.
सर ऐसा very simply अगर हम
Yeah, it's
मैथ्स को छोड़ दे तो इंटीग्रेट कर देते हैं इक्वेशन को बस.
so that's why I am giving you this example. I will I claim that we are not able to solve exactly a very simple problem.
Yes.
So that's why
Yes.
some
And we definitely हम अगर मतलब if for in the language of a layman, if we ask someone, then can you just solve it, then he don't know the definition of existence and uniqueness and all other
no,
things. He
ma'am.
just
Even if if I say great mathematician and ask him that solve this problem, he will not
definitely yes.
able to. Because we don't have any method to find
Yes.
the solution of this problem for journal F.
F.
Even not
Right.
journal in the sense it's satisfying all the nice condition to have the exact to have its solution, and that is unique.
Yes,
It's
yes, sir. You are
and
right.
this and that. But still we don't have any problem. Any method to find the exact solution. You might have
Right.
observed. For particular, if you take it's a linear one. If it's a form of y square y power n, it's a type of Bernoulli equation. You can solve that in very particular way. Am I right?
Yes,
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 sir. Yes,
But
sir.
in general, you have. So I have given you the two things. Right? For one, we are able to find the exact solution, but for this toy problem, we are not able to find the exact solution, or we don't have
Right.
any methods to find the exact solution. That's why we need to do something more than that. And of course, I need not to say that it's a very important problem. You observe if I take the particular form of this y is equal y is equal to fx equal to y raised to the power n. Eh? And so then we have somebody give the solution of this. So you see the importance of that. So behind his name, it is known as that problem. Am I right? So it
Right.
means that we can say that if we talk about the mathematical problem in terms of differential equation, so the differential equation for which we have method to find their exact solution, we can count on finger. Am I right? But
Yes,
at
sir.
the same time, all you are mathematician, maybe many of you are from applied background, or if not, so all are aware. You see, the mathematical problem which model the real life problem are very, very complicated in nature. Am I right? So for
Yes, sir.
that, for most of the, I'm claiming, for most of the problem, we are not able to we are not able to find the exact solution. Am I right? Existence and uniqueness, that is discussed when we say that when we model a real life problem. So that step only when we model that. So that is a I mean the integral component of that. We have to discuss about existence and uniqueness of the solution. But the next step I am talking about, the next step, I mean, if suppose भाई हमने क्या किया कि कोई real life problem थी, वो हमने mathematical problem में convert कर दी, तो वो तो, और फिर उसके बाद जो हमने existence uniqueness उसकी कर दी, well pose दिखा दी, और फिर कह दिया भाई खड़े हो गए, तो उससे तो काम नहीं चलेगा ना भाई. आकाश से गिरा, वो खजूर पर लटक गया, उसे तो नीचे आना है ना भाई. हमें
Right.
solution चाहिए basically. Am I right?
Right, sir.
So
Yes,
that
sir.
is also integral part और very very important. भाई अगर पहले आना तो नीचे है, पर खजूर पे आ गया तो चलो फिर खजूर के बाद देखेंगे. आसमान से कम से कम खजूर पे आ गया, वो भी important है. तो but at the same time the solution methodology is important. But I told you, and I am making another claim, that the most of the mathematical problem which model the real life problem are very very complicated, and for them we don't have any method to find the exact solution. So the now another one way is that, say okay, yeah, leave that. We convert a real life problem into a mathematical problem, then we discuss its existence and uniqueness. But after that we found that we are not able to solve this. So the one way, or we are not able to find the exact solution of that, the one way we should leave that problem. Am I right? Another way, okay, we are not able to find the exact solution, can we find the approximate solution? We should check. So what we will do, or what you would do, Sarfaraj?
Yes.
Sarfaraj?
Yes, sir. We try to.
Yeah.
We
try to find.
we try to find some approximate solutions. Yes.
So this thing is clear. So that's why I mean this is important. And the first component is, are you agree, is very very important. The development of method to find the solution of approximate problem. Am I right?
Yes, sir. Yes, sir.
This is very very important. So we should do that. Now the second one, ठीक है ये तो है, we should also look whether this approximate information works or serve our purpose. भाई हमने जो है approximate solution find कर लिया, उससे तो हमें कोई फायदा ही नहीं हुआ. इससे तो ये था कि भाई खजूर तक आए, फिर वापस आकाश में जाके फिर दोबारा से मतलब ट्राई करते हैं.
Yes.
Model in another way. So now we should understand whether these approximate information are sufficient or serve our purpose. So now this was the first claim. It's I think okay, all of you are agree. Now my second claim. What is my second claim? My second claim that in most of the practical situation, these approximate information is more than sufficient. Now my second claim, I am claiming the approximate information is more than sufficient. In most of the situation, we do not require exact information. So are you agree with that?
सर मतलब मैं समझी नहीं, मतलब क्या कहना चाहते हैं आप कि most of the problem do not have the
in
exact.
most of the practical situation, even we do not require the exact information. We are happy with the approximate information.
Okay.
So are you agree with that?
Can you give us some example of how we can say this?
Yeah, so anybody else can give some example? Yeah, of course I will I will do that at the end. Anybody else? I mean, just tell me.
We don't need.
I mean, it's a two-way. We are just discussing.
Yes.
I think many of you are the teacher, and I am also a teacher. So we are just discussing. So anybody tell whatever you think. So somehow, ma'am is a little bit convinced, but not much.
हाँ, मतलब I was just thinking, even I am also thinking कि ऐसा किस तरह की situation, नहीं कैसा नहीं, मतलब in which situation or which type of problems we are encountering in the daily life, where we can say that we don't need the exact solution, only the approximation solution works.
We are happy with the approximate information.
Approximate solutions.
Yeah. Anybody else? Rajneesh, can you say something?
Yes, sir. Yes, sir.
Yeah.
Hello. Yes, sir.
Yeah. Yeah, please.
Yeah. Yes, sir. Please. What is the question?
So you go to, I mean, bed and then come back in between. So actually, I made another claim. I claim that in most of the practical situation, we are happy with the approximate information.
Yes, sir. Yes, sir.
So, ma'am, Lakshmi ma'am is saying that, can you give some example? So I'm looking for an example. So can you help me out?
Rainfall. Rainfall, temperature distribution.
Just like, sir, landsliding on mountains.
So so ma'am, I mean, you have to convince not me, Lakshmi ma'am, because I am already convinced. So ma'am.
So that means you're talking about all this data collection problems where we.
No, I will give you very, I mean, practical example. But first, I am expecting it's not a technical thing. All of you are aware. Okay, I am giving you now. So you see, suppose in weather forecasting.
Yeah, weather forecasting, temperature
बाजार
distribution.
जाना है, भाई घर से निकलना है, ठीक है, बाजार के लिए. So this information, whether it would be a rainy day or non-rainy day, I think this is sufficient for you. If it would be a raining day, you would go with the umbrella. Am I right?
Yes, sir. Yes, sir.
जाएंगे. अगर नहीं है, कितनी बारिश होगी? Am I right?
Yes, sir.
Yes, sir.
In financial forecasting, that what would be the trend of the market in the coming days, yeah, in the near future, that whether it would be in upward direction or downward direction, this information is more than sufficient for an investor.
Approximate solution is sufficient enough to predict any future things.
I mean, no prediction तो है ही ये, but ये कि भाई हमारी जो ये prediction है ये useful है कि नहीं है. But I am saying that भाई exact की जरूरत ही नहीं है हमें. In population forecasting, भाई exact जो है, suppose करो 10 साल बाद नोएडा की population जो है 10,000 होगी, 10,000 and 200 होगी. अगर किसी ने आपको बताया कि मैम ये लगभग 10,000 के होगी, so this information is sufficient.
Yes, sir.
Am I right? So in most of the practical situation, we do not require the exact information. अगर suppose करो exact ही हमें पता चल जाए कि भी 10,221 होगी, तो I mean it's hardly matter. After 10 years. So I mean to say that these exact information are important. So we should even I am making more one more claim that rather than go for the exact solution, we should not try even. We should go with the approximate. Even if it is very complicated, we have some procedure to find the exact solution of a mathematical problem, but it is very costly, maybe computationally costly, or maybe very complicated. So rather than that, we should go for the approximate one. So this thing is clear. Hello.
Sir. Yes, sir. Yes, sir. Yes,
Yeah.
sir.
So I think you are convinced with my second claim also. So this now I am coming to, so the first part is well established. What was the first part? First part was that the development of method to find the approximate solution of a mathematical problem. Now we are coming to second part, that analysis of the error occurred in the approximation. So now I am asking you why we should do analysis. भाई हमें solution तो मिल गया, ठीक है नहीं भाई, हमें solution मिल गया, और वो जो solution था, बार बार क्या, भाई solution हमें मिल गया, वो solution जो है भाई approximate है, वो I also claim that भाई जो approximate solution है और information है, that is more than sufficient. तो now तो भाई हम second क्यों करें, analysis की क्या जरूरत पड़ी? Anybody can answer?
Yes, sir.
No,
Analysis.
just tell me your views. I'm not expecting that whatever I think you should also think in the same way. But
Yes, sir. जैसे कि जब हम approximate बोल रहे हैं, sir.
Yeah, please.
Right. When we are talking about approximate, maybe an approximate is different for me, and then the same problem has different approximation solution for you. Maybe जैसे अभी अपने population का ही कहा नोएडा में, तो कोई 10,200, कोई 10,300, कोई 10,400 अपने हिसाब से उसकी approximation देता है. Different method or approaches से. But which approximation is closer to the exact solution?
मैम जैसे सपोज करो किसी ने जो है बताया भी 10,300, किसी ने बताया 10,500, किसी ने बताया भाई 9,900.
Right,
So
sir.
I think both will serve my purpose.
But
Why I require to do? I mean, I don't know how many of you are working, particularly in the numerical analysis. How many of you are working?
So काम तो कर रहे हैं, ऐसा नहीं है. I think I also doing.
अच्छा, तो आप सोचो ना मैम कि you will see development of method is I mean little bit easy when we go for the analysis of these method. It's
Yes, sir.
I mean require I am not aware whether you tried, but you see that it require more than the analysis which the person who are doing analysis.
Yes, sir.
So
Yes, sir.
this part, but I mean this must be also good or maybe important.
Definitely, sir. Definitely.
So anybody else can tell something? Anything? Okay. Yeah. So you see that suppose now I am giving you another example. So where it board is there. Actually थोड़ा psychologically, हालांकि नहीं भी लिखो ना तो भी थोड़ा सा वो रहता है क्योंकि आदत वही है ना mathematician को, तो without board it would be difficult.
Yes, sir.
Yeah. So now I am giving you another situation. If suppose I ask you, or in the population forecasting, basically we are if you observe roughly, we are 10,000. So we are I mean allowing error of roughly order 10 raised to the power minus 2. Am I right? भाई अगर 10,000 or 10,200, 300, 400 है, so I am allowing error of order 10 raised to the power 2. Are you agree?
Yes, sir.
By whether its population would be 10,000 or 10,100 or 10,200. So basically, I am allowing error of order 10 raised to the power, not minus, sorry, plus 2. Am I right?
मतलब 10 to the power raised to 2
Means
मतलब 100 तक का
100.
error we are allowing.
100 के मैं I mean 100,
अंदर
200, 500, 600 or maybe in the reverse direction. Am I right?
But not after that. अगर वो
No,
1000
no,
में आ
just
गया है.
I am giving you roughly. Yeah.
Okay.
Not after.
Yes.
I mean, if somebody say that okay, it would be 15,000. Somebody say it would be 5,000. So that is not acceptable. Am I right?
Yes, sir.
That is, so we can tolerate the error of order this. Now I am giving you another example. Do you remember Gulf War? Practical example I am giving you. Gulf War. Gulf War, it was between US and Iraq.
Yeah, मतलब we read about the problem. Yeah.
हाँ तो वहाँ क्या हुआ था? I mean US has a Scud missile. What it used to do? It used to destroy the weapons in the air or missiles in the air.
Okay.
So what happened? One Scud missile was failed. So I mean, because of that, one missile from Iraq was destroyed the camp of a US Army, and it was I mean casualty around hundreds and other thing also. So then they analyzed. Then they found that there was error of order 10 raised to the power minus 8 in some calculation. And because of that it happened. So I mean to say, in situation number 1, I am allowing error of order 10 raised to the power 2, and in another situation I am not tolerating error of 10 raised to the power minus 8. Am I right?
Yes, sir.
So I mean to say that when we are developing the method, so the user must be aware before using. He must be aware that what would be the error associated with the method or tool. Am I right?
Yes, sir. Yes, sir.
Like suppose we have two method. Method number one has has error of order 10 raised to the power 1. Am I right? Method number 2 has error of 10 raised to the power minus 10. Am I right? Now we have these two methods, and suppose being a student of mathematics, let us assume कि भाई दोनों सिचुएशन में सेम ही प्रॉब्लम को हमें सोल्व करनी है, but one situation we are allowing error of this order and another we are not allowing error, or we are allowing error of suppose order 10 raised to the power minus 9. Am I right?
Yes, sir. Yes, sir.
So now tell me which one we suppose we are in situation 1. So which one we could use? With the one way, with the blind eyes, we can say that the best one we should use.
We should use it definitely.
Yeah, this second one. Am I right?
या यस सर, सेकंड ही लग रहा है अभी तो, उस हिसाब से अगर हम सिर्फ ऐसे ही
And anybody else can say something?
Sir, I think your board is not visible.
Okay. And now it's visible.
Yes, sir.
yes sir.
Yeah. So in first situation, ma'am is saying that we should use second one. Anybody else can say? In the second one, there is no, I think, argument. In second one, we should use second. Am I right? But in first also, I think many of you are aware about no free lunch theorem.
नहीं सर, नहीं पता.
भाई ये है कि मतलब अगर कुछ हमें गेन हो रहा है तो उसके लिए वी हैव टू गिव समथिंग. एम आई राइट? कि भाई
Okay.
जनरली ऐसा नहीं होता.
हम्म.
In some situation it would be, but in general, अगर I mean we are getting better accuracy, so we sometimes we need to pay something more than that.
Yes sir.
भाई अगर कोई ग्लास है, एक स्टील का है, एक I mean सिल्वर का है, तो then we need to, I mean silver it would be better, but we need to pay more money. Am I right?
Yes sir, yes sir.
So that's why भाई हमारा जो काम कर रहा है, अगर हमें नहीं पता था एरर के उसमें, बस यही पता है हमें कि ओनली भाई ये बेटर है या ये है, so in that way we will use the best one. Am I right? But if before applying, if we would be able to know that in which how much error would be there, so then we can talk about or we have choice that which one we should use. Am I right? Or if we I mean if we have two method and we do not have any error analysis, or we do not know any procedure to find the error before using the method, so we have to do hit and trial. Am I right? And sometimes it is not acceptable. Like in the case of war, which would happen there if I would use the method number one, so then things would be worst. Am I right? So we cannot do experiment.
Yes sir, yes sir.
You agree? So that's why we should be aware about the error. Or even in the first situation, it would be, if I'm using this one, so maybe I would get the result quickly. In this case, we will get accuracy, more accurate information, but for that I need to pay more, and I don't have that much money. Am I right? So in
Yes,
that
sir.
case, also this first one will also work. So are you agree? So it means that we should analyze the method for error. So this thing is clear.
Yes sir.
So now
Yes sir.
all of you are aware, I are convinced that the definition which I gave you, now I'm also making one more claim, that you will not find this definition in any of book or anywhere in Google. Or did you anybody came across with this definition of numerical analysis?
No sir, no sir.
And now are you convinced with that or no?
Sure sir, sure. This is very much convincible.
Yeah, because
Without any prior knowledge of any methods or techniques, we
Yeah.
have to
yeah, so in that
take
way
the
analysis
where the error is less. The error difference must be less.
yeah,
in
and
that way.
so the definition of numerical analysis is that number one, it is consist of two part. Number one, the development of method to find the approximate solution of a mathematical problem. Number two, the analysis of error occurred in the approximation. So now
Yes, sir.
come back to our problem. So anybody have any doubt till now?
No, sir. No, sir.
So now we come to the problem.
क्या?
Initial value.
दिया ही नहीं मैंने, इमरान से दिया था एक बार, इमरान से हो रहा है फर्स्ट फ्लोर पे। हाँ, अपना वाला।
IVP initial value
इमरान और तो
problem है. The method to find approximate solution of initial value problem, and what we will do in that? Evolution, not evaluation. Evolution. You understand that how method were evolved. I'm not giving you the any new method. So I will tell you that how methods are evolved to find the approximate solution of this initial value problem, because all of you are convinced that we are not able to find the exact solution of this initial value problem. Am I right? So now I will explain these so now you forgot all the method to find the approximate solution of this type of problem, mathematical problem. Just forget for a moment. Am I right? Not for the always. Just delete from the not delete. Just keep somewhere else. So we do not know any method to find the solution of this initial value problem. Am I right? We are not talking about now exact solution. We are just talking about the approximate solution. This thing is clear?
Yes, sir. Yes, sir.
Yeah. So now what we do? So we have to find the solution of this problem. So how we should do that? Anybody can answer? For what type of thing would be the solution of this problem? Suppose this is true for all x. I'm giving because every differential equation has a differential associated with the differential operator, and this is true for all x belongs to I. I is an interval. Am I right? So now first we should see that what type of thing we are looking for.
Yes, sir.
So tell me.
Sir,
We are looking for some function. Am I right?
Yes, sir.
Which
Yx. We are looking for
y.
yx.
Or you can say that
An
some
unknown function y.
Yeah. So we are basically looking some function which is defined on I interval. This yx. Am I right?
Yes, sir.
X. What type of property this function should have? That
It must be continuous and differentiable.
Yeah, of course that property have, and this satisfying this
Initial condition.
This differential equation, as well as at the
we have given its value at one point,
yeah, and
prescribed value at.
this type of things we are looking for. Am I right?
Yes, sir. We
Hmm?
can do it from Taylor's theorem.
हाँ, वही है कि भी कैसे करें, बताइए तो आप
सर
बताइए।
अप्रोचेस तो बहुत है, बट अगर हम इनिशियली शुरू करें
नहीं, बट मैंने तो ये कहा है ना कि वो वाली अप्रोच अभी टाइम बीइंग भूल जाइए। बस
अच्छा,
हमें तो
तो
एक ऐसा फंक्शन फाइंड करना है कि भाई जो इस डिफरेंशियल इक्वेशन को सेटिस्फाई करे और ये बाउंड्री इनिशियल कंडीशन को सेटिस्फाई करे।
ओके ओके
या प्लीज ट्राई।
so that means we are looking out for that capital F whose when we differentiate it with respect to x, ऐसे कैसे बोलें?
Sir, we will get a Volterite integral equation, which is phi x is y0 from x0 to x, f of x yx ds. We are looking for phi x, which will be a Volterite integral equation. Hello?
Yes.
Because
Anybody else? Because okay, I'm just giving you the flavor that I will tell you that how these methods, all these method, Taylor's method, Picard method, these Euler method, multi-step method, must have evolved. Must have
So
evolved
then we
means
can
at time
what
researcher who developed these method might have think. I don't know whether I'm right or wrong, but I'm telling you, I will tell you with my experience. Yeah. So suppose
right,
we
sir, then
have
suppose सर अगर इस तरीके से हमें डेवलप करना है कोई मेथड तो we know the value at x naught, यानी कि the starting point is x naught,
x0. So then
x0. Then we have to say or we can make this y dash equal to fxy to be one singular form, in a single expression, say y dash minus fxy is equals to 0, something like this.
yeah. So we will start from let. Am I right?
Yes, let.
In mathematics we can do that. But लेट कई बार जो है ये लेट जो है वो भी हो जाता है खतरनाक। एक बार ऐसे ही एक क्लास में जो है टीचर ने कहा कि भाई मान लो कि भाई आपके पास जो है 10 संतरे हैं। स्टूडेंट ने कहा कि सर मैं तो नहीं मानता। नहीं भाई, मतलब नहीं मानता क्या भाई, मेरे पास तो नहीं है। मान लीजिए उसमें मानने में क्या है, मैथमेटिक्स में मान लेते हैं क्योंकि ठीक है सर, मान लिए 10 संतरे हैं। आपने जो है 2 राम को दे दिए, 3 जो है शाम को दे दिए, तो बताओ कितने संतरे बचे। उसने कहा कि जी 8 संतरे बचे। लेकिन 8 कैसे बचे कि सर जैसा आपने मानना था ऐसे ही मैंने मान लिया कि 8 बचे। बट in mathematics we used to do that. Well, let phi be the solution of this initial value problem. So it means that this satisfying the differential equation means phi prime is equal to f and phi at x0 is equal to y0. By these two things I have. भाई कहीं जहां भी मुझे जरूरत होगी मैं वो यूज कर लूंगा। Am I right?
Yes, sir.
I say that let phi be the solution of this initial value problem. It means that phi prime is equal to f. Phi prime is equal to f and phi at x0 is equal to y0. This thing is clear. So now my problem is, rather than solving this in an initial value problem, now my problem is transformed to another problem that now I am looking for phi. Am I right?
Yes, sir.
So rather than phi, now I am looking for the right hand side भाई जो भी राइट हैंड साइड में मुझे इस टाइप की चीज मिल जाए, फाई एक्स इज इक्वल टू समथिंग विच इज रिटन इन द राइट हैंड साइड एंड दैट इज गिवन. व्हाट आर द गिवन हियर इन टर्म्स ऑफ एफ? भाई एफ गिवन है और वाई जीरो. भाई ये भी मुझे पता है. अगर ये इन्वॉल्व होते हैं तो कोई दिक्कत नहीं. तो अब क्या करें? भाई नाउ व्हाट वी शुड डू? ये तो ठीक है. Now we want phi in terms of given things. So we know the value of y or value of phi at x naught. So what should be the first step? That we should involve x naught. Am I right? Because I know the value of phi at x naught. So I will write x as x naught x naught plus x minus x naught. This thing is clear? There is no harm in doing that. Am I right?
Yes, sir. Yes, sir.
Yeah. Now you look that now we involved x naught. Also, we know the value of phi at x naught. Not only value of phi at x naught, I know phi prime at x naught also. So the next way is should be, we should write this thing in terms of phi at x naught and its derivative at x naught. So we can do that using the Taylor's method.
Yes, yes, sir.
Am I right? So phi at x naught, suppose I am denoting that phi 0 plus
X minus x naught.
X minus x naught. So time being, suppose if I denote this by h.
Yes, yes, sir.
So yeah, because it's difficult for me to write it. So phi prime at this one plus
h square upon factorial 2.
Yeah, h square upon factorial 2. So I'm just writing 2 phi double prime
at x naught.
Yeah, at x naught and so on. So in that way we would have dot. This thing is clear. Now we look whether on the right hand side everything is known. If everything is known in the right hand side, our work is over. Am I right? So now look, phi 0. What is phi 0? Phi 0 is y 0.
Yes, sir. Initial start.
Yeah, initial, and it is known. So I have written phi 0 is equal to y 0 plus h times h time. What is phi 0 prime or phi prime 0? Anybody can tell? Because phi satisfying this one.
Sir, f prime.
So it is f, not f prime. F
Del of partial derivative.
no, not partial derivative, because y prime is equal to f. So phi satisfying this. So phi prime is equal to f.
Yeah. Yes,
So
yes.
f 0. Now look, the next one, h square by 2. Now can anybody tell phi 0 double prime? Do we know that?
Yes, we can differentiate it once.
Yeah. So please, can we do this for me and tell me?
I think del f upon del x at x naught.
I don't think so. Something more than that, because it's a now variable of this is a function of two variable. Am I right?
X, y.
So you have to use Leibniz formula. So please do that. what is phi double prime? Phi double prime is dy by dx of phi prime, and phi prime is f, so dy by dx of f. So calculate dy by df, dy by dx of df of dx. Tell me. With differentiation of several function of several variable. भाई क्या होगा d by dx of f is equal to curly f by curly x into dx by dx plus curly f df by y into
Sir,
dy by dx. Am I right?
yes, sir. Del f upon del x into dx upon dx plus del f upon del y dy by dx.
Yeah. So क्या हो गया हमारा? हो गया f x0. Am I right?
Yes,
fx at 0 0 0 x0 and plus
fy fy
yeah f
fy at
fy
zero.
at 0. Am I right? fy at
0
into
into dy by dx is f of x naught.
so f0. Am I right? So this is also known.
Yes, sir.
So this thing is clear. So in that way they must have developed the Taylor series solution. Am I right? भाई अब क्या होगा, इससे अगला क्या होगा? h cube by factorial 3 means h cube by 6 phi triple prime 0. So you can find that also in that way. Hello. So please find out that also, phi triple prime. Please find out phi triple prime at x0. Hello.
Yes, sir.
Yeah. So did you calculate? तो ये तो आप कहेंगे कि सर ये तो एग्जैक्ट सॉल्यूशन ही हमने निकाल लिया. We are running towards finding the exact solution.
Yeah.
But
Yes,
there is no approximation till now we made. Am I right?
yes, sir. Yes, sir. Yes, sir. But it's a infinite expansion.
Yeah.
So we have to approximate now.
Yeah. So in that way, there is no limit for finding. Yeah, even the things would also going to be complicated step by step. But anyway, we can do that. We can do that. But we do not have any procedure to find the sum of this infinite series. Am I right?
Yes, sir. For journal F.
Yeah. For any f we do not have any procedure, so that's why we have to truncate somewhere. So in that way we will generate or
Yes,
we
sir.
will have the approximation.
Yes.
Am I right? So
How
then
long we will take the solution? We will get that amount of affine solution.
yeah.
If are more than fourth order or fifth order, so we will get some more affine solution. Like
Yeah.
we can approximate range equal to fourth order. So we are getting some solution. But if we'll approximate more than that, so we will get more refined solution.
Yeah, you see that means whatever we are living, so that is nothing but that is the error. Am I right?
Yes,
So
sir.
if we have two, I mean one step, so then this much error would be there. If we have two terms in the solution, our solution, so we have this much error, so it's reducing. Am I right? If we are
Yes, sir, because H is very
more,
small. So order of H is also very become more small.
no, I understand that is going to be smaller and smaller. Naturally, we will take H. Oh, that is the second thing. But if you think means if we are leaving this component, if we are in this entire, or we can say that okay, these three terms is the our solution, exact solution. So if we keep one term in our solution, am I right? So we
Yes,
will
sir.
get approximate solution. If we have another solution in which we have two term, so then we have another solution, but that is more accurate. Am I right? If we
Yes,
have
yes, sir.
three terms, so in that way, because we are leaving that part, whether it's H is small or not, that is another thing. This thing
Still
is
we will
clear.
get. Yes, yes, sir. Yes, sir.
Yeah. So in that way, this Taylor's or the method using the Taylor series might have evolved. So anybody have any doubt till now?
No, sir, it's clear.
Because I think I need not to tell you, or in assignment one can intuit, one can give you some example for that. But I think the concept I have conveyed for that. Or anybody have any doubt? So please let me know. Or regarding this Taylor's approximation till now, when many of you might have teaching, any doubt anybody have? So I would be happy to answer. No doubt anybody have? So we should move further.
Sir, I have one doubt.
Yeah, please.
Yeah, you're
Because
talking about
you already we have in several books we have. Yeah.
Yes, sir, yes, sir. Like you're talking about partial differential equation considering the heat equation.
Yeah.
But like in the heat equation, if we are taking the Dirichlet boundary conditions, so we will get the unique solution.
No,
But
that is the another thing. Yeah. I mean I can answer that also, but in that way we do not have end to that. My focus is that in what reference I have given you the I mean lecture. So in that way you should pose the answer. Am I? Oh, sorry,
okay,
question.
yeah, right.
Am I right? Otherwise, we
Yes,
will go in the arbitrary direction. If you have, we can discuss at some another platform.
yes,
So please ask question. So if you think at the after one, I mean in 1 hour we can do that, but we have very limited time. 2 hour today, I think we have 2 hour tomorrow, and I have to do lot of things. So my focus is that I'm just telling you what is my motive. My motive to convey you, first thing I have conveyed, that what is numerical analysis and why we should do numerical analysis.
yes,
If
yes, sir.
still anybody have any doubt, so I would be very happy. Another things I wish to convey that these method I'm just naming also: Taylor's method, Picard method, or these Euler method, modified Euler method, trapezoidal method, Rangakuta method, and these multi-step method. Eh?
Yes,
So
sir, yes,
these,
sir.
how these method might have developed in the, suppose it was started from the Taylor series. Now once you see the what is the beauty of this Taylor series method, you can find the approximation or the solution with desired accuracy. Are you agree?
Yes, sir. Yeah.
Desired accuracy है कि नहीं है? And
Yes,
this is
sir.
the best thing in the approximation theory. भाई
Yes, sir.
अगर हमें लगा कि फर्स्ट टू टर्म के बाद एरर ज्यादा, वी कैन टेक थर्ड टर्म. इफ
Yes,
स्टिल वी थिंक भाई एरर इज मोर, वी कैन टेक फोर्थ
yes,
टर्म
sir.
एंड फाइव एंड सो ऑन. दिस थिंग इज क्लियर.
Yes,
So
yes,
now
yes, sir.
things. Now your question should be that then why we should move, because right now we know that except Taylor's method, also there are number of methods are available. So why
Yes.
these methods must have developed? भाई ऐसे ही तो नहीं, we should not, neither we should teach for fun, neither we should study for fun.
Yes, sir. There is
वो तो
some.
नहीं पढ़ने ना, ऑब्जेक्टिव था भी मैथमेटिक्स पढ़ने का, मैंने ऑब्जेक्टिव बताया आपको है. I think most of you must be convinced. It may be some of you know. Generally, sometimes it's happen, but most of you are convinced. Am I right? Then
Yes, sir.
I'm teaching you numerical analysis, because IBP come under the umbrella of numerical analysis. So
Yes, sir.
I taught you that concept also, and I told you that why we should study numerical analysis. Now, my next approach, which I will teach you in the coming days, that the methods, how the methods are evolved to solve initial value problem, IVP. So this thing is clear. So whatever till now we have studied, so please ask question related to that. This thing is clear?
Yes, sir. Yes, sir.
So please, anybody have any doubt while you were teaching or studying this Taylor's method or numerical analysis? Anybody have any doubt? I will try to solve. No? Okay, so now I am asking again you the question that it's fine. So what is the beauty of this method? This method give you, or this approach give you a method with the desired accuracy. So now my question, because you know that Picard method you are aware about? Hello?
Yes, yes.
So why we should study, or why we should develop another method? Let's say why we should go for the Picard method. We need to find out, it means some drawback. तभी तो मोटिवेशन मिलेगा पढ़ने नेक्स्ट मेथड पढ़ने का. अदरवाइज व्हाई वी शुड स्टडी और व्हाई वी शुड डेवलप. चलो स्टडी तो फिर भी कर ले, पर जिन्होंने रिसर्च करके इतनी मेहनत, ऐसे थोड़ी हो गया जैसे आई थिंक वी हैव डेवलप इन हाफ एन आवर. भाई आधा घंटा थोड़ी टेलर्स मेथड्स डेवलप हुआ होगा.
There should be some limitation.
हाँ, so what are the limitation?
Because we are interested in more affine solution. So we are going.
Affine solution means affine or fine, you are saying?
Means more accurate.
Rather than fine, you should use more accurate. But in that, it's up to you. भाई जितना accurate चाहिए उतना accurate दे देगा ये तो. Given epsilon, you will have a method. भाई जितनी तुम्हें एरर छोटी चाहिए उतना ही ये वो दे देगा. Take more and more term. Am I right? And anybody else? Any other thing?
Akshay is saying something.
Who's saying? Yeah, Akshay, please. Akshay?
Sir, maybe computational power we have limited.
Okay. In some sense, it's fine, but computational power in what sense?
If we need more accuracy, then we need to take higher terms, so it will be take more times in our computers.
Yeah, it's made more time, but accuracy we are getting the desired accuracy.
But suppose that it will take exponential, it will take 1 year to compute accuracy 0.01 more, so it will
So, but till now we did not get that such type of method. Suppose why the author, the researcher might have developed Picard, but Picard also have this low accuracy. not high accuracy it has. Anything else? You are close to the answer. Anybody? But you see that when you compute these derivatives, am I right? Even by hand you can find out y double prime, y triple prime. Even these are also it's a cumbersome process. But anyway, we can do that. We can find its 10th derivative, which is very cumbersome. But you see, when we compute these derivative, we have considered this is a scalar one. Am I right? Acha, one question I ask you, you might have seen in most of the time, or we have more focus in studying the first order initial value problem. Why we do not study nth order initial value problem? Anybody can answer?
Because sir, most of the real problems we like growth model or logistic growth model. So we are getting the rate of change of x with respect to time or any other dependent variable.
Yeah, one answer is this also. It is the more practical one.
Yeah,
but
like carbon dating model first discovered. So we are getting dx by dt. Equal to or any, if you are interested, very much interested in land population in India, so we know that dy by dx is always proportional to y. How many lands present?
I
right
understand. I fully agree with you, but I mean there should be some other region also. Why this is the one?
So
Higher order ODs can be converted to system of ODs of initial.
Yeah, best nth order initial value only, not OD, just nth order initial value, not the boundary value.
yeah, we can make it in the system of differential equation.
Yeah, we can convert to the first order system of initial value problem. Am I right?
Yes, sir.
So
Any second order or third order.
So it means, but when we develop the method to the new method for the the system of equation. So first step we should develop method to the scalar and then extend to the system. If you remember, if you remember in RK method, Rangakuta. So Rangakuta, these are the two mathematicians. Am I right?
Yes, sir. Yes, it's true.
Yeah. So Ranga developed the method in I think 1896, around 1896 for the scalar. Then Kuta developed these or extend these method to system. So that's why these are known as the Ranga-Kuta method. So that's why we, most of textbook or most of the time we study, or when we, develop the new method, so then we start working on the first order scalar initial value problem. This thing is clear?
Yes,
yeah. So now we come to the what are the drawback, which would motivate us to go for the other method to develop. Am I right? So one drawback, if you see that, because when we compute the derivative, am I right? These are very costly computationally, as Akshay told. Yeah, it is way, but we have to see what is creating the problem. The one way it is naturally computationally costly, but what was the reason? The reason was because of derivatives are involved, and here you see why derivative. Once we have scalar one, so then there is nothing to worry. Still we can find the solution. We can it will not much costly, but when we dealing with the system, then these derivative will be replaced by the Jacobian. Are you aware about Jacobian?
Yes, sir. Yes, sir. Derivative in higher dimension will convert it into
Jacobian. And in that case, what would happen? In that case, when we do computation, so then matrix will involve, matrix inversion will involve, and matrix inversion takes a lot of computation, or it is very costly computational.
Yes.
So this derivative is creating the problem. So that's why we are interesting to develop method which are derivative free. This thing is clear?
Yes, sir. Yes, sir.
Yeah. So to get rid of derivative, so what is the best way? What is the best way to get rid of the derivative? It's a integration. Hello?
Yes, sir. Yes, sir. Yeah.
So
Integral
now,
equation make the things easy.
yeah, so now we are moving towards that how might have Picard method would have developed. So we just integrate the differential equation from x naught to x. X naught to x. So what we have on the left hand side? We have y yx minus y at x naught. Am I right?
Yes, sir.
So we take y at x naught on the right hand side.
Yes, sir.
Y at x naught is equal to y0 plus integral x naught
X
to x f
of SYS.
x.
We can change the dummy variable as well.
Yeah, we can change. You can change if
Dummy variable by S.
J or S. Yeah, S
Yeah.
would be more easy.
More easy to write.
Yeah.
DS.
Think it's clear?
Yes, sir.
Yeah.
Which is
So
good.
now, भाई हाँ अब क्या हुआ वही प्रॉब्लम हो गई ना भाई अब rather than solving the differential equation है now I mean there is no derivatives involved. Am I right?
Yes, sir.
So this one. तो वही दिक्कत होगी कि भी अब वो आसमान से गिरे खजूर पे लटक गए कि डिफरेंशियल इक्वेशन की जगह इंटीग्रल इक्वेशन.
Sometimes, but sir, integral equation is easy to solve.
Yeah, it's easy to solve, but now we have to solve here. So how we should do that?
One method is use the Laplace transformation.
No, but actually my focus, I think you are again moving towards, I say, okay, forget about the method, but I does not mean that. I mean that I try to, I mean, explain that how the researcher might have moved from Taylor's to Picard to Euler to Rangakuta to multi-step method.
Yes.
Yeah, so
Yes,
that's
sir.
why. So in Picard method, what we do? So okay, just forget about Picard, but we are moving in that direction. So now we will see that how we do that. Once we should try to narrow down our problem. So actually the differential equation was creating the problem. So we have converted that, integrate that, and now rather than solving that differential equation, now we try to solve this integral. Now what things here is creating the problem? But suppose f would be a function of s only. So then it is very easy to integrate. Am I right? By suppose this fsy is equal to s square.
Yes, sir.
Hello?
It's easy to calculate.
Yeah, easy to calculate. So it means that the unknown is sitting on the right hand side. Basically, we are looking for y, yx. We are looking for yx, and that ys is sitting on the right hand side. So this is creating the problem. So what we did, we basically approximate this, and we generate a sequence of approximation. How we do that? yn plus 1 yn plus 1
is yn
is equal to tell
yn
yn. ये तो यहाँ थोड़ी कुछ करना है हमें,
y0
इसे करेंगे ना, इसे जो है हमने ये n+1 पे रख लिया हमने, ठीक है,
so
और जो
initial
unknown was sitting on the right hand side उसे n पे ले लिया.
yes sir Picard
So
iteration.
in that way we have a recurrence relation. Am I right?
Yes.
Put n is equal to 0, n is equal to 0, we will have yn, y1. Put n is equal to 1, we will have y2. And when we put n is equal to 0, so on the right hand side we have y0. So here when we generate a sequence, so then we require one recurrence relation and the first term of the sequence. Am I right?
Yes.
Yeah. So we take y y0 is equal to y at x naught. Very good.
This is first iteration of the Picard.
Yeah, and so in that way we will generate this sequence of approximation. And I think when you were doing that the initial value problem, theory of initial value problem, so you might have observed that this sequence as n tends to infinity converge to the
even
solution.
uniformly converges.
Yeah, solution phi x, a function phi x, which is a solution of the initial value
problem.
Or in sequence, if a sequence converges to the any solution, so what does it mean? It means that as you are going, if you are taking first term of the sequence, so it will give, of course, it will give you the approximation to the phi.
Yes,
if you take second term of the sequence, so you will have the better one, third better, and n tends to infinity, you will reach at the end. And in this case, we do not require any evaluation of derivative. Am I right? So we get rid of, or we got rid of the calculation of derivative, which we have in the case of Taylor's approach. Am I right?
Yes.
But here now do we have the beauty, do we retain the beauty of the Taylor's method? What was the beauty of the Taylor's approach? That we can generate a method with desired accuracy. So do we have that beauty?
Yes, sir. Here we are doing.
Yeah, we can take next term
large enough, so we can expect.
If we feel that, if we calculate y1, and if we feel that by y1 in y1 we have more error, so we can take y2, y3, y2, and yn plus, y1, y2, y3, y5, y6, and so on. Am I right? So I think somebody raised the hand. Yeah, please. Hello. Yeah. Hello.
I think, sir, it's by mistake.
अच्छा, by mistake. Okay. कोई बात नहीं. तो अब I think now things is clear.
Yes, sir.
So now your one exercise, that now you have to find out drawback of Picard and Taylor's method, so that we could be able to generate a method like Euler's method. Am I right? So what is assignment for you people today? Find out the drawback of
what are the limitation of the Picards and a Taylor approximation
iteration, so that we can move to Euler type method. This thing is clear, or I should say that the step marching method. Yeah.
Yes, sir.
These Euler method are known as the step marching method. This thing is clear. So anyway, so please ask any question till now. because we have class lecture till 5. Am I right?
Yes, sir.
Yeah. So please, anybody have any doubt?
Yes, any queries from the participant side?
So anyway, if you do not have any doubt, so then come with the आंसर tomorrow है यही नहीं पूछ लेना कि सर यही डाउट बता दो ये क्या लिमिटेशन है इनकी
Sir, I think जो भी उनके doubts थे, they asked side by side, ना?
okay
And you elaborate each and everything in a very interactive manner. So that is one of the most important aspect of this session. Each and everyone is feeling that we are connected to the Professor Kapil Sharma, sir.
okay.
So thank you very much, sir, for sharing your knowledge and expertise about the differential equation with all the participants. And we are really very thankful to you so that because you act as an integral of this TEW and you explain each and every step in very detail and in a very interactive manner. I hope all the participants have really explored this session and conceived it in a very elaborate manner. I am also thankful to all the participants of this session and all the faculty members of Department of Mathematics. And my sincere gratitude to our head of the department, Professor Ma'am, for her continuous support. So tomorrow we will again connect with the same link at 3 p.m. And then Professor Kapil Sharma sir will continue the session. So thank you very much, sir.
And ma'am, to whom I should mail the assignment so that you people can do doing the tubes.
Right, sir. You're right, sir.
I will give you the solution. So, but first, the who will take the tutorial should not give the solution. But if he requires, so he can. Okay.
Right. Very.
I will mail it.
You can mail it to Lakshmi, Dr. Lakshmi.
Okay.
Right. So we will proceed according to that only.
Okay.
Thank you very much, sir. Thank you to all.
Thank you, sir.
It's my pleasure. Thank you. Bye.
Bye.